NASA's Artemis 1 mission is making its way to the moon, starting a new era of lunar exploration. Using communications and navigation services from the Near Space Network, based at NASA's Goddard Space Flight Center, and the Deep Space Network, based at NASA's Jet Propulsion Laboratory, the Artemis 1 mission will be able to communicate critical tracking, telemetry, and science data to Earth. Services from both networks are integrated at NASA's Johnson Space Center in Houston.
The INCO console is tasked with managing the communication systems on Orion, making sure that we can send commands to the spacecraft to tell it what to do, receive telemetry and data back from it, receive video and pictures from it.
The Orion spacecraft is launching from NASA's Kennedy Space Center in Florida aboard the Space Launch System rocket known as SLS. Close to Earth, it will receive communications and tracking support from the Near Space Network, a global system of ground antennas and satellites that provide either direct-to-Earth communications or relay communications.
The NSN, or the Near Space Network, is an integrated network that provides RF, radio frequency, and terrestrial communications to both NASA and non-NASA spaceflight missions.
They support human spaceflight missions like Artemis, but they also support the launch vehicles like the Atlas V and Delta IV. From a communications perspective, the early phases of mission pre-launch and launch and early orbit are going to be covered by a new communications system, ground stations, called Launch Communication Segment, or LCS. Once SLS has jettisoned, the vehicles will transition over to TDRS communications. Orion itself will remain on TDRS for roughly 2.5 hours into the flight, or after that, transition handover to the DSN, or the Deep Space Network.
The Deep Space Network consists of 3 global antennas that can communicate with spacecraft far into the galaxy. The network will serve as Artemis 1's primary communication support as the spacecraft orbits the moon, similar to its role in the Apollo days.
The Deep Space Network antennas were used during the Apollo program to track the missions, the Apollo missions, but we would help the Apollo spacecraft do navigation, we'd do communications to and from the Earth to the spacecraft, which included the videos that you see of the astronauts on the moon. The Deep Space Network, it exists today. It can support missions at the moon. It will continue to support Artemis 2, Artemis 3, with the first astronauts returning to the moon.
The Near Space Network and the Deep Space Network have a storied legacy in supporting moon-bound missions. To this day, space communications and navigation are central to communicating and tracking all missions, from near Earth to as far as interstellar space. Now, as Artemis 1 journeys to the moon, NASA sets its sights on the future of exploration, bringing the next humans to the lunar surface and eventually to Mars.